Hello children, in continuation with the previous video, we are going to learn the ray diagrams in case of curved surfaces, that is concave and convex lens. But first of all, we need to learn few principles, or you can say few conventions that we use to make the ray diagrams. Okay, so we actually call them principal rays. Okay, three rays we talk about, and these three rays are actually used to make the ray diagrams. For ray diagrams, children, you need to remember actually two rays are required, but sometimes in board exams they ask you to draw all the three rays. Okay, so we need to learn about these. Let's see. The very first thing, as we were talking about optical center, that this is your convex lens, this is your optical center, right? And same way for your concave lens, this is your concave lens, right? This is the, I can extend it, this is the principal axis, and this is the optical center. Okay, so what was there? That a ray passing through optical center, after refraction, it passes undeviated. This is a ray passing through optical center. After refraction, it will pass undeviated. Same way with concave lens. A ray passing through optical center. After refraction, it will pass undeviated. And the second principal ray that we are going to talk is a ray. Okay, first of all, let me draw. This is your convex lens, right? This is your optical center, and here a ray parallel to principal axis. After refraction, it passes through focus. It passes through focus. Second focus I'm talking about in case of convex lens. This is your, and I hope we remember because we have done ray diagrams in class 8th and 9th as well. F1 and F2, these are going to be equal in case we have the same medium on both sides of the lens, right? And when we draw ray diagrams, we assume that there is existing the same medium, right? So a ray parallel to principal axis, after refraction, it passes through second focus. But when we talk about concave lens, again, this is your principal axis, this is your optical center, and then we have your second focus, and this is your first focus. Okay, so in this case, a ray parallel to principal axis, okay, after refraction diverges this, but when you extend, it passes through second focus. Fine. And the third principal ray that we are going to discuss is a ray passing through focus. A ray passing through first focus, after refraction, becomes parallel to principal axis. Okay, so this is F1, F2, and a ray passing through principal focus after refraction becomes parallel to principal axis. And what happens in concave? Same way, the same thing is going to happen, but let's see how the ray is going to behave. And is it the same thing we are going to have here also? Optical center, right? So we have here F and F, right? So we have F1 and F2, and we have done that a ray, it becomes parallel to principal axis after refraction. Okay, and if now you can ask me, in this case you told that a ray is passing through first focus, but here you have not shown. Yes, you have to simply extend it. Okay, so a ray passing through first focus, after refraction, it appears to actually. Okay, so I can say a ray of light passing through the first focus, F1 in case of convex lens, or it is directed towards the first focus in case of concave lens, it emerges parallel to the principal axis. Okay, after refraction. So these are the principal rays that we need to take here. Now the next concept that we are going to learn is, and we'll be using these terminologies frequently while drawing the ray diagrams, that is your real image and virtual image. So what is a real image and what is a virtual image. We have done these while doing mirrors also in class 9th. So a real image is formed due to actual intersection of the rays refracted by the lens, like we were talking in terms when we were discussing convex lens. Right now we discuss the three principal rays. And in case of virtual image, a virtual image is formed when the rays refracted by the lens appears to meet if they are produced backwards, like we were talking while talking about concave lens we did, right? A real image can be obtained on a screen, whereas a virtual image, it cannot be obtained on a screen. Fine. A real image is inverted with respect to the object, whereas a virtual image is always erect. Okay, erect with respect to the object. Okay, so now we are going to start with the ray diagrams, and I would like to start with convex lens first of all. Okay, convex lens. So the very first case that we are going to discuss is when the object is at infinity. Now when I say when the object is at infinity, actually we discussed two types of diagrams here, right? So if I say object is at infinity, whenever we talk about infinity, we always show the rays coming parallel to the principal axis, right? In that case, this is the thing. This is your optical center, rays parallel to principal axis. This is your optical center, principal axis. And we remember from our principal rays, right now we did the three conventions that a ray parallel to principal axis after refraction passes through focus. It passes through focus. Fine. So if somebody asks you, what is the nature, what is the characteristics of the image formed, then what you are going to say? It is a real, inverted and diminished image, isn't it? How come real? Real, it's on the other side. You are able to obtain it on the screen. Real, inverted, though it is pointed, but actually it is inverted. And it is on the, it is inverted, real and diminished. If you see here, if I'm saying diminished to a point, fine. So it is real, it is inverted and it is diminished, right? And we also discussed the second case, that is for far off objects. If I say far off objects, again, this is your lens. And by the way, what is the difference between object at infinity and object far off object? When I say infinity, I mean to say you just imagine stars. You can see the stars, right? But you can't actually have a guess at what distance they are lying. You are able to see, but you don't have any approximation. But if I say far off object means if it's just like, suppose I go to my terrace and I just see the surrounding. I can make out that stadium is just 600 meter. It may be that building is 1 kilometer and so on, so on. It means I'm able to make an approximation, right? But stars, you can see stars at night and they just appears to be the image, the dot object, right? And the objects at infinity are always shown parallel to the principal axis. But when I say far off objects, they are again shown parallel to each other, but not to the principal axis, right? So for this, I have a ray passing through optical center. When it is passing through optical center, we remember that it will pass undeviated, right? And the second ray, it is passing through the focus, okay? F1 and F2. Children, I'm not using geometry here. So what I'll be drawing is actually approximation. You have to draw these diagrams using geometry. Fine. So I know when an object is passing through first principal focus, after refraction, it will become parallel to principal axis. So approximately here, I'll be getting this is F2, right? So approximately here I'll be getting the image, right? This will be A dash, B dash, and this is actually F2. Fine. So what about the characteristics of the image formed here? Again, it is on the other side, that's why it's going to be real. Other side of the lens, that's why it's going to be real. If you check out, if you check out, I have written A dash B dash. This is inverted image will be formed. When we talk about real image, it is the inverted image. Whenever we talk about virtual image, it is the erect image. Fine. So it is real, inverted, and it will be highly diminished. Fine. Highly diminished. Highly diminished. Okay. And what about the next? Next is when the object is, this was infinity. Now let's talk about the second case, when the object is beyond, when the object is beyond 2f. This is O, F, 2f, right? And this is your second case, beyond 2f. So beyond 2f, suppose I'm having this object AB, right? So this is your object AB. Now, a ray parallel to principal axis. A ray parallel to principal axis. Again, I need to write here F, 2F. Fine. A ray parallel to principal axis. F1, F1. After refraction, I know refraction should be exactly from the center. It passes through focus. Second, a ray passing through focus after refraction becomes parallel to principal axis. It becomes parallel to principal axis. I'm writing it here, okay? So when I'll be getting this, it will be like this. For you people, it might be because the ray, it seems that this is a bigger one, but actually you will be getting a small image, okay? So we have, because it's again on the other side, it is your real image. It is inverted because real, inverted. And what next? It is going to be, it's going to be small in size, or you can say it will be diminished, okay? Small in size. So the third is when the object is at 2f. When the object is at 2f. This is your optical center, right? F1 to F1. This is F2 to F2. When the object is at 2f, right? I'm labeling it as AB. Ray parallel to principal axis after refraction passes through focus. A ray passing through focus after refraction will become parallel to principal axis. So it will be, here you are going to have the image A dash B dash. Again, on the other side, real image, inverted. And if you check out, AB will be equal to A dash B dash. This is going to be inverted image and it will be of same size, right? This is going to be of same size. Fine. And the fourth is when the object will be between F and 2F. So let's work on it. But before that, I would like to tell you, sometimes in board exams, they ask you to draw the 3 rays. As I told you, for ray diagrams, only 2 rays are required. But sometimes in board, they ask you to draw the 3 rays. So what is the third ray here? We know third is when a ray passes through optical center, it passes undeviated. It means when a ray from the object is going to pass through optical center, it will pass undeviated and automatically it will meet here, right? So this is about the third ray. Same way here also you can check out. Again, a ray passing through optical center passes undeviated. So when it's going to pass through optical center, it will pass undeviated, right? So you may even expect such type of question in board exams. So next is the fourth part, as I told you, and it is when the object is between F and 2F. So I have this lens, right? Again, principal axis, again F1, F2, F1. This is F2 and this is 2F, right? Between this. And I'm labeling the object as AB, right? So we have again, I'm just going to opt for the 2 rays now, but I have told you how to draw for the third ray, right? So here again, a ray, again draw the center, right? A ray parallel to principal axis after refraction, it is passes through focus. Let it be here, focus, okay? So this is, and a ray passing through focus, after refraction becomes parallel to principal axis. So if you can make out here, it's going to be this A dash B dash, right? So what about the characteristics of the image form? Again, it is on the other side. It means it's a real image. Real, that's why inverted, right? And what about the size of the image? And you can say it is formed beyond 2f, right? So it is beyond 2f. Beyond 2f. And what about the size? It is magnified. If you check out here, the image is magnified, right? So the next case is, again, when the object is at 2f. The next is when the object is at f1. So again, it's very simple, you know, if you remember the three conventions how to draw, the three principal rays that we opt to draw the ray diagrams, it becomes very simple, right? So again, we have when the object is at f1. Again, this is the object AB. And children, in exam, it is must that you must write down here that AB object, A dash, B dash, image, and then about the characteristics, the nature of the image form, that also you need to mention, right? So next is again when again you need to draw the center, right? You need to draw the center. Again, a ray parallel to principal axis after refraction passes through focus, right? And you need to draw the rays as well, because rays depicts where the light is going to move. But what about F? I can't pass the ray through F, isn't it? Can you see here? I can't make the ray to pass through F like this. So what is the other option? The third ray, that is a ray passing through optical center. It passes undeviated, right? A ray passing through optical center passes undeviated. And bache, I'm not drawing it with geometry. That's why I'm getting like this, but otherwise it will come out to be like this. Can you see? So again, the image is on the other side. That's why real. Real image, that's why inverted, right? Inverted image is there. And what next? It's going to be infinity. It's going to be magnified, highly magnified it's going to be, right? So where the image is formed, first of all, it is going to be formed at infinity. And what sort of image is there? Since infinity, it's going to be highly magnified, right? So this is the case when the object lies at f1. Now the next case is when the object lies between f1 and O. Again, principal axis, draw the center. Here is the optical center, f1, 2f1, f2 and 2f2. So what is the next aim? To find out how the image is going to be formed when the object is between F and O, right? Again, a ray parallel to principal axis after refraction passes through focus. And what about again? Now it is difficult to pass through focus, right? So what is the next option? That is to pass through optical center. Okay, let me pass through the optical center. It's going to be like this. So from here you can make out that the lines are not parallel to each other. So if you extend them, they are going to meet somewhere, right? They're going to meet somewhere. And where that image is going to be formed? It's going to be formed here somewhere, isn't it? This is the image. So don't you think so? This is this is the only case where image is formed on the same side as that of the object. That's why it is virtual. Always remember, virtual image is erect image and real image is inverted image. Okay. So it is virtual, erect. Where the image is formed? It is formed before 2f, or you can say between f and 2f, f1 and 2f1, right? And what about the size of the image? It is highly magnified. If you compare here, this is the object and this is so large, right? So here again you can write down the image is highly magnified. So if you check out if you have checked all the ray diagrams and if you have understood, actually I started from infinity, right? And the image was formed at focus. But when I started from 2f, the image was formed here. When I started moving the object this way, the image also started shifting this way. When it was beyond 2f, it was between f2 and 2f2. When I kept it as 2f, it came at 2f2. When I kept it between f1 and 2f1, it just went away from 2f2 and it was beyond 2f2 and so on. So this is how it is. Just the same distance is going to be this, it's going to move this way. Fine. So these are the ray diagrams, and for convex lens, only one case where virtual image is formed, right? And virtual image such that it is highly magnetic.